Right, okay. Last day we discussed about representing integers or the
Yeah,
numbers, right? Representing numbers, the negative and positive numbers, and I have suggested few methods. Method number
figure
one
question.
was sign and magnitude. So basically, in this method, so what we do is converting the number to the natural binary number and representing the sign using 1 or 0. So if sign is 1, it is negative. Sign is 0, it's so sign bit is 0, that is positive. So these are two examples how we represented positive, this plus 10, and same, this is minus 10. But so I have given some mathematics, actually calculations, and ask you to calculate and see. So there are some fundamental issues in this sign and magnitude method. So for an example, plus 37. If we convert plus 37 to sign and magnitude, we will get plus sign. And 37 is like, you can say 37 is 32 plus 5. 5 is 101 and 32 is 0, 0, 1. So this one. So altogether 1, 2, 3, 4, 5, 6, 7, 8, right? This is plus 37. Did you get this value?
Yeah.
Right.
Yeah.
This is 1. 1 plus 4 is 5. 5 plus no 8, no 16, 32. 32 plus 37, right? Okay, then negative 12. Negative 12 is minus, and you'll have 1100 for 12. It is negative 12. So how you calculate? Basically, you have to subtract 37, subtract 12 from 37. So 1 minus 0 is 1. Then 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 1 you can't deduct. Again, so you have to bring 1 from here. Oh, so you can take the whole thing. This is 1, 0, 0, 1, 0, 0 mean 4. 4 minus 1 is 3. So you can indicate that. And then the remaining will be zeros. So answer will be plus. This value is 16 plus 8. 16 plus 8 is 24, 25. 25 is the answer. So I ask you to do the same, right? Similar calculation. Right, okay. So I think hope you get this. So anyway, so you will not get this kind of mathematics in your examination. Even you get this kind of mathematics will be easy because you can do this using 37 minus 12. You know the answer. Answer is 25. 25 you can represent in sign and magnitude. No? So that is, so then you can cheat because easy to cheat. So therefore they won't ask questions like that. But why I have given this kind of question? Just to identify the issue. Basically, you have to subtract. You have to subtract the first one. The second one, both signs are negative. So this is now I have to make this negative. So since signs are negative, this 37 is also negative, 12 is also negative, then signs are negative, I have to add the numbers. But first one, because of subtraction, I had to subtract. Second one, because both signs are negative, I had to add. So I can't subtract now. Now let's add 1 plus 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 2. 2 means 0 remainder 1. That 1 plus 1 is 2. Again 0 remainder 1. That one will come here and the next one will come here. So then 0 will be 0. And since signs are negative, I have to manually think and put the sign as negative. Because 1 and 1 again 0, no? 1, 0, no? But forgetting that, I have to put 1 here. 1 plus 1 is not 1. But minus and minus is minus. I have to think like that and put that. That is a bit confusing because we have to use our sense with the computer sense, which is quite hard in computing. Computers can rationally think. But as human beings, we can think intelligence.
So we have to, second one, we have to minus it.
Which one?
Second, 37 minus 12.
37 minus 12, yeah. What is the answer?
I have added it.
Yeah, you have to add. Why? Because
have added.
minus value, if minus value is added to the minus value, you know, so there should, the answer for this question should be minus, so if I calculate, so this is 1 plus 16 plus 32 is 48, 40, 49, minus 49. So this is the answer for the question. 2 plus, this is 9 and 49. Minus 49 is the answer. You have to go for that answer. That is the answer for this question. That's why you have to add.
I
Did
got
you
1
understand
1
or not?
0 0, 3 1 and 0.
No, after adding, you will get this value. That is, that might be wrong calculations. That's it. If you add, you will get here 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 2. 2 means 1 0. Remaining 1. 1 plus 1 is 2. 2 means 1 0. Again, remaining 1. That 1 will come here. Then this 1 plus 0 will be 1. So this is the answer of addition.
So minus 37 is 1 1 0 1 1 0 1 0, right?
Minus 37 is, yes. So this is plus 37. If plus 37 is this, minus 37 is just minus sign. That's all.
That's it. Then no need to invert like the whole.
No. So this is sign and magnitude. In sign and magnitude, no inversion.
So that will be only 1, no?
Yeah, that sign will become 1. That is sign and magnitude. There's another number system that is called 1's complement. In that case, you have to invert. But in sign and magnitude, no inversions. Just change in the beginning digit. That's all.
Then 37 as it is.
37 as it is, only change the minus sign. That's all.
12 also. We don't need to change the 12 to
No.
minus 12 now.
Nothing to change. That is
We just
simple.
find.
That is simple, natural as we see. But the thing is, bit complicated in calculations. Because in calculations, you have to, you have different rules. No unique set of, no, actually no, so you cannot be, so no single method of doing the calculation. So the first one, if plus 1 is bigger than the minus 1, you have to subtract. Second one, both are minus, you have to add. Third one, both are plus, you have to add. Fourth one, plus 1 is smaller than minus 1. Then what to do? Then again, you have to subtract the smallest, sorry, biggest one from the smallest one and write the answer as negative. Right? So there's no formal way of doing that. So there are formal ways there, but anyway, it's not simple. Case by case, you have to think. If both are plus, no worries, add the numbers. If both are plus, no worries, just add the numbers and you will get 47 as the answer. So if both are plus, you are safe. Both positive, this case you are safe. You just add the number, it will give 49. So answer is correct and you are safe. If both are minus also, you are safe because you can add the number and put the minus sign in the beginning. If both are minus, both are plus also you can add, both are minus also you can add. But if one is negative, then you have to think wisely. If the smallest one is negative, you can deduct 12 from 37. Here, if this one, here 37 is the negative one. Again, you have to deduct the 12 from 37. Right? But that is not the thing. But what actually you have to do, you have to subtract 12 from 37 and write the answer as minus. Right? So that's the because of this reason, because of this subtraction issue, sign and magnitude is not used in computers. So sign and magnitude is better for us because we know what to do with the number, but computers cannot, so it cannot think that much. It actually doesn't like to think. Due to that reason, so still you can write this 37 and 12. Okay, assume that there's something like this, plus 12 minus 37. Then again you have to swap the numbers and write. 37 you have to write in the top, minus 37 on top, then the Then come the plus 12. Right? So likewise, so this swapping, changing. So these computers won't like this because it doesn't want burden. So this is a burden, additional burden. So answer will be again 25, but this time minus 25. Minus 25. But that is additional burden to the computer. Right? So due to this additional burden or this additional rules or additional thinking, so computer engineer were thinking that so this is not going to be a good method in computing. So therefore they have suggested another method, and this has another problem. So you can see the plus 0 is there, minus 0 is also there, right? So computers doesn't have something like that, no? Even in mathematics you don't have plus 0 and minus 0, but in sign and magnitude you will have plus 0 and minus 0. That is also a problem. So due to these issues, right? Due to these issues, what has happened due to these issues? So sign and magnitude was removed from computing. So it was not used inside the computer. Now we are not using sign and magnitude in the computer. The issues, main issues. Issue number 1 is positive and negative 0 issue. So you can write down. The issue number 1 is plus 0, minus 0 issue. Issue number 2 is the subtraction issue. Right?
Yep.
Issue number 1 is positive, negative 0 issues. Issue number 2 is subtraction issue. Therefore, SNM, sign and magnitude, was removed from this computational representation. But still, so you can use that because it is human friendly. We can understand that, but computers won't. Computers doesn't like that. It doesn't like that. So just let's move to the next number system, which is ones complement. Right, in this complemented system, whatever you said, that reversing part will be applied. Right, positives are represented as usual, so no change in the positive, but negatives, magnitude will be inverted.
So the other thing, sign and magnitude, that like low chance, right? Or coming to the exam?
Cannot say like that. So because even though it's removed from computing, so if so since you have it in theory part, so they can ask calculate this in sign and magnitude. Because all three number system, all three representation methodologies are there in the syllabus. Right? All three representation methodologies are there in the syllabus, so they can ask. Right? Okay. So write down the second heading, ones complement representation. And here positives are represented the usual way without any change, but negatives are represented using the negative sign bit with the inverted magnitude bits. Okay, please write down this. Okay, here positive numbers same, no change, right? Positive numbers, no change. Negative numbers, this is how you write the minus 10 in sign and magnitude, but so excluding the sign, you invert other bits. Here, invert the other bits means you have 000 will be represented using triple ones. Then 1010 will be 010. That's the reverse inversion of the number. So the advantage of this, right? Advantage of this is, so here, so when we represent the numbers, you will not get subtraction issue because you can do everything by addition. Right? So let me do this using the previous example that we tried this one. I'm going to use the same thing and try to do the same using this time using ones complement. Right? Let's say I have this, okay, ones complement number systems, and I'm going to I'm going to, yeah, so let's take a new file. I'm going to do the same calculations. So same calculations, this time is using ones complement. Ones complement. So plus 37, no change, but minus 12, there's a change. What's the change? Minus 12.
Minus 12.
This is not the one that I'm going to use. I'm going to use, yes, you can tell me the value. 1.
No, minus 12 is like 1100, right?
Yeah, you have to tell me the value. Tell me the value. 1.
1111.
0, 0, 1, 1. The reverse. Okay. Now I'm not going to subtract. I'm going to add the numbers. Tell me the addition values, right? So, okay, after adding.
You're taking plus 12.
No.
Minus 12 is.
This is minus 12.
Plus. Okay. Plus 12 is only the top one, right? I think.
This is not going to. This is
yeah.
like this is the sign and magnitude answer now.
Yeah.
But that we are going to remove. Instead of that, we are going to use 1's complement value.
Okay.
Right? So then what we are going to do is we are going to add 1 plus 1. What is the answer? 1 plus 1 is?
1 plus 1 is 0.
2. Yeah, 2, you write 0. Then take the 1 to the next level. Then again 1 plus 1, 2. 2 means 0. You take 1 to the next level. Then again 1 plus 1. Again 2, you take 1 to the next level. Then 1 plus 1 this time is 1. 1 plus 0. So
1.
This is also 1. 0 plus 1 is also 1. And 1 plus 1 will be 2 and 0 will go here. This 1 will go here. 1 plus 1 will be 2 again. 1 will go here. This 1 plus 1 is also 2. Again you have 1 remaining. That remaining 1 you have to add again. That is the additional burden here. That remaining 1 you have to add again. Now what is the value? 0, 0, 0, 1, 1, 0, 0, 1. Okay, after that, so what is the value? What is the answer of this? Now convert this. This is 1. 1 plus 4 is 5. 5 plus, 1 plus 8. 1 plus 8 is 9. 9 plus 16 is 20. 25. So you got the correct answer. It's 25. That is correct answer.
I did this method only for those.
That is 1's
complement.
That is 1. So 25 is the answer. You got the same answer. But this time using addition, right? This time using addition. So no. So now you can see the advantage of using sign and magnitude. So using 1's complement over sign and magnitude. Because in sign and magnitude you had to subtract. But this one you have to add. Addition will give you the correct answer. So that is the advantage. Understood of using 1's complement, the advantage?
Yep.
Yeah, subtraction issue was solved. Now you don't have that kind of complex subtraction is not there. Instead of that, simple addition is there. Okay, let's take these two numbers. So is it correct in 1's complement or wrong?
1 minute.
This is minus 37. Minus 37 in 1's complement. Is it correct or wrong?
37 is wrong.
Wrong. So you have to write 1, 1, 0, 1, 1, 0, 1, 0. So this one also you have to write like 1, 1, 1, 1, 0, 0, 1. So both numbers you have to invert because both are negative numbers. So this is not going to use and this is not going to use. Both are negative numbers. We have to invert. And after inverting, so you have to add. After inverting, you can add the numbers. Tell me the values by adding. 0 plus 1 is 1. 1 plus 1 is 2. Remaining is 1. That remaining 1 will come here. That 1 plus 1 will be 1 here. 1 plus 1, 0. Remaining 1, 1 plus 1 is 0. Remaining 1, 1 plus 1 plus 1 is 3. 3 means 1. And again, 1 plus 1 plus 1 is 3. 3 means 1. And the remaining 1 should be added again. When you add this again, you will get this value 1, 1, 0, 0, 1, 1, 1, 0. And this is the answer. Is it correct answer? 1100 Is it correct answer?
1 minute.
Sorry?
1 minute. I can check mine. Yeah, I got that. Exactly.
You got that this answer.
Yeah.
This is one's complement answer of this, and one's complement answer. Let's see. So how to check whether this is correct or wrong?
Again, you have to, if we multiply that.
Again, you have to buy why because this is a negative answer. No, you know the negative answers will be inverted answers. Now you have to convert that to positive by reversing. So let's reverse this. 0 you can reverse as 1, and triple 1 will be triple 0. Then double 0 will be double 1, and then this 1 will be 1, that is negative 49. So this is the relevant sign and magnitude to the this one's complement answer. Right? You have to, so because sign and magnitude only we can understand, the negative and the value that we can understand. So this is inverted one. No? Inverted one you have to re-invert and see like sign and magnitude. That's why I said in the exam you may get sign and magnitude, because that is what we can understand.
We when they give this question, what if we write this is the final answer, then okay, right?
If they are sign and magnitude answer, this is the final answer. If they are one's complement answer, this is the final answer. If they are sign and magnitude answer, this is the final.
Just
next one
invert
is
this and okay, can do this. Okay. Sign and magnitude only the first number will interfere with the digit, right?
Your first number no change because that is the sign. No?
Yeah, okay.
Okay, the next one is both positive. Both positive, is there any difference or same? If both are positive, one's complement sign and magnitude, is it different or same? Same. If both are positive, so no change.
Answer is also correct.
Answer is also same. And this kind of thing, so you have to just change the negative one. Order doesn't matter, right? You can write 37 up or 37 down, it doesn't matter. Because you are doing addition only, no? You are not subtracting.
Yeah.
Minus so addition only, so it's 1 1 0.
Yeah, 1 1
1 1
0 1
0 1 0. And then you have to just add the numbers. And so only thing is you have to add the numbers, that is all. So just after adding, you'll get okay, so let's say let's add 0 plus 0 0, so 1 here, 1 plus 1 is 2, 2 again 2, and here you'll get 1, and here 1 and 1. So this is the answer that you get. And you have to invert that. You have to invert that. After inverting, 0 will be inverted to 1, double 1 0. Okay, so inverted 1, and you know this is minus 25. This is sign and magnitude, and it is equal to minus 25. And this is the one's complement answer. Are you okay with this? I have done quite fast away.
Yeah.
But I think it's okay. So
no, because I did that first. I did thinking that as this, so I got that easily.
No, so don't confuse, right? Sign and magnitude is different method, and this is different method. One's complement is different method. So one's complement is the solution. So one's complement. So basically, one's complement is the solution to sign and magnitude.
Yeah.
Right. So both are not same. One's complement is the solution given, but this solution also has a problem. So what is that? So this additional one come in when overflow, because you have to add the bit again. So additional one, you have to add it again and calculate the overflow bit. That is a problem. The additional one should be added again. So that is overhead. We call overhead, unwanted thing. And there's another thing. So other than that, so there's another issue. So similar to the previous one, right? You have the negative and positive 0 issues. Here, this one is a positive 0. Similar to that, the inverted one will be there, that is negative 0. Right? So you can just show this, right? Example representing this. And so issue number 1 is, so the highlighted points you can write down. Issue number 1 is positive and negative 0. But anyway, issue number 2 is solved because subtraction was solved by creating But it has also created another sub issue, that is the re-addition issue. Just write the English one only, right?
So the issues for the sign and magnitude.
Okay, sign and magnitude. What is the first issue? Sign and magnitude. The first issue is positive and negative zero issue.
Negative zero. So
what is the second issue? Okay, positive and negative zero issue.
Yeah, done.
What is the second issue for sign and magnitude? Second issue for sign and magnitude is subtraction issue.
Yeah.
Right. Subtractions, you have to subtract. Those are some fundamental issues. But to solve that, one's complement was introduced. Again, one's complement will have this positive and negative zero issue. It is still not solved. Here you can see by this example. Sign and magnitude had positive and negative zero. Here, this is plus zero, and this is minus zero in sign and magnitude. So yeah. So okay, so let's say
like it doesn't have, right, one's complement. How come it has?
Why?
Like
which one?
Sign and magnitude.
Sign and magnitude, yes.
No, one's complement. One's complement doesn't have, right? Like only if we go to like change it to the integer, then we have like those two numbers.
I think still you have not realized, you have not understood the lesson. It seems
Kind of confusing.
The confusion is because you are always trying to find a shortcut. You try to skip one by one. You think because you think that you know, thinking that you are trying to skip. So first, my recommendation is go to the 0th level. Think like a beginner. Go one by one. Otherwise, if you are උඩ කැලකුත් දන්නවා යට කැලකුත් දන්නවා භාගයක් කියනකොට you will automatically assume that you know that. So you are not concerning on that. Therefore, you will miss that. That's the simple reason. So if you carefully learn the first number system, so when I ask you to write down, there are two issues. One is positive and negative zero issue. I said that. One is positive zero and negative zero issue. What is positive zero? This is plus zero. What is negative zero? This is minus zero. You had that issue, right? You clearly show by the calculations. When we do the calculations, you clearly show that, right? When we do the calculation, you clearly show that we have to subtract. Did you understand by doing that?
Yeah.
Subtraction issue is there now. So you should understand that, not learn, right? Not by heart, not study. You should understand that. So this is plus zero, this is minus zero. This issue was there. And so the second issue was subtraction. But subtraction issue was solved with this, because by now you can do everything by addition, right? But still this positive zero is there. Still negative zero is also there. Did we remove that? No, still those are there. But different way. Not the same way, different way. So this is plus zero in sign and magnitude in S and M. And this is minus zero in S and M. And this is plus zero in one's complement. This is minus zero in one's complement. Still that zero issue is there. So it's still not solved. Still that zero issue is there. Because you can invert and write that. Even though you have changed the way of representing negative, still you can invert that. That inverted one will represent negative zero. Understood or not?
Yeah.
Then, so one issue was solved. So one positive point is this. addition only. Now you don't want to use this subtraction. But it has introduced another issue. What is that? Overflow bit re-addition issue. It has introduced new issue. That is overflow bit re-addition. This bit, whatever the bit overflow, you have to add it again to get the answer. Right? So that's why I ask you to write this and write this to show the which is solved and which is unsolved. So forget about what you have learned. So if you keep that in mind, so it's not clear. So it's like you try to clean the room and like you try to rearrange the room, but you still keep some old stuff there. Then when re-addition, you have to do two things. You have to like put the old stuff in the correct place and also bring the new stuff and keep room for them. But so, first, what you can do is first clean the room, clean everything, remove the old stuff, remove the new stuff, everything. Then bring one by one. Then it is well organized. Otherwise, your mind will become less organized. You cannot find the thing, you will confuse.
Yeah.
Right? Remove everything. Forget that you learned this lesson previously. Learn from the beginning. Then you later you can match with the stuff that you have learned. So whether there are holes or not, whether there are some issues, whether there are misunderstandings, then you can clear it out. But first clean it. First clean it. Clean mind is required.
From this addition part, after they introduce that, the positive and negative is gone. No, only the overflow is an issue. So
still this part is there. This issue is still there. Negative 0 issue is there. But only addition is subtraction issue was gone. Subtraction issue is now solved. No subtraction issue. But positive, negative, 0 issues are there. And overflow bit issue is there.
Okay.
Actually, so we wanted to solve two questions. Initial question was positive, negative issues. It cannot be solved. Still remain. The second issue that we wanted to solve is subtraction issue. That was solved. But solving that, we have introduced new issue. That is overflow bit re-addition issue. Okay, so you can just learn this. Maybe, so this lesson is not this much tough. Right? Maybe when you learn school or when you learn in a tuition class or any other normally a regular place. So what they say, sign and magnitude, change sign, one's complement, invert, two's complement, add one. So then lesson is over. But the issue is, so when they ask questions in deeply, why? So logical, if they ask question, why it came from this method to this method? What are the issues in these methods? Likewise, if they logically ask small question from this area, students will struggle because they don't know. They know there are three methods, that's all. Right? They don't know why there are three methods.
Yeah.
Right. That is why I'm going to give you this knowledge too, right? So take it positively and learn this. Then no need to study this again because you know how it happened with the history. Okay, so to solve this, actually the third method was introduced. What is that? That is two's complement. So here, same positive numbers, no change. This is the third method now. The first method is sign and magnitude. Second method is one's complement. Third method is, what is third method? Is two's complement.
Two's complement.
Two's complement method has same positive number representation. But for negatives, it has a small addition. So that is basically negative represented by inverted, similar to the one's complement. But additional one will be added to the end. That is the only change. Right? So learn the change. So then it is easy to.
Sir, could you repeat that once again?
So same. So can you remember sign and one's complement?
Yeah.
So what's happening in one's complement?
So when you put like
Positive numbers in one's complement.
everything will be added.
Positive numbers. How to show positive numbers in one's complement? Is it different from sign and magnitude or same?
That's same.
Same. Okay. Then what about two's complement? Is it different in two's complement or same?
Same.
Same. Right. Now you have to remember only one point. What is that? Positive numbers in all three methods, same. Understood? Okay. Now you have to remember only one thing. That's what education is. When you learn and learn and learn, it should be simple.
Yeah.
It should not be a stack. Then what happened when you study lesson by lesson by lesson by lesson, it keep adding things. But it is not core, it is not learning. Learning should simplify the matter. Right? Learning should simplify the things. So, okay, for an example, so are you driving? Are you doing any riding or driving?
Yeah.
Right. Okay. So when it comes the first day driving and today driving, so which is simple? The first day or today?
Today.
Today. Because you learned it. Learning should simplify, no? Otherwise, so if learning keep adding this, if keep adding the syllabus, now driving is more complex than yesterday driving, or now driving is more complex than the first day driving. What is that learning? This is not learning, no? That is keep adding things. So that is making it complex. So that is the fundamental error. In learning, you should simplify. Now you have learned three methods, no? First method, sign and magnitude. Second method, one's complement. Third method, two's complement. After learning the third method, everything should be simple than the earlier.
Yeah.
What is the simplicity? All three methods, positives are same.
All the methods, positives are same.
Same. Okay, what about the negative? In the first method, negative is just the sign.
Sign, yeah.
Just the sign. The second method, negative is sign with the inverted magnitude. The third method, sign with the inverted magnitude plus 1.
The one
That's all. Sign, the first positives are same. Negatives, first method sign only. Second method, sign and inverted. So once complement කියන කොට, so remember that complement. Once complement means the reverse. Complement means the reverse. Once complement means, unlike the sign and magnitude, complement is reversed, or the magnitude is reversed. The complemented part will be there. The two's complement means reverse is still there, but additional one will be added. That is the only change. Remember the change, then it will be simple.
Okay.
Right?
So for
okay,
two,
so
only one will be added.
Only one will be added. That's all. So that is the ultimate lesson. After everything, after 1 hour lesson, so things are now more simple, should be more simple than the first 10 minutes. So that is the expectation of the lesson. So if you learn like that, that will be easy, right? Okay, so let's take a number now. Let's take a number and try to represent in all three methods. Okay, I'm going to take plus 37. Okay, tell me in sign and magnitude, and tell me the value in one's complement. Then the value in two's complement. Sign and magnitude in, so we have already done this, so I'm going to write this. Sign and magnitude is 0, 0, 1, 0, 0, 1, 0, 1, correct?
Yeah.
So this 1, 0, 1 is 5, 5 plus 8, no, 16, no, 13, yeah. Then, so what about one's complement and two's complement? Still the same. Same and same. So no difference. Okay, minus, let's say minus 37. Sorry, minus 37. minus 37. Minus 37. And this one you have this minus. This one you have minus and the inverted part. That means 1 0 1 1 0 1 0. Okay, you can tell the third one. So what is that? 1 1 0 1 1 0 1 1. Understood?
For third one,
You just add 1
at the end.
at the end. That means you have to add plus 1. This one plus 1.
So like the front plus 1 in the first one plus 1 in the front, and
so 2's complement is simply 1's complement plus 1.
okay.
That is the easiest way of writing this. 2's complement is 1's complement plus 1. That is for negatives only, right? That is for negatives only. Okay, can you represent these values? 0
Yeah.
in all three methods. And minus 0 in all three methods. Can you quickly write 0 and minus 0 in all three methods? Also minus 127 in all three methods. Can you quickly write? The first one is easy, right? First one is easy. It's 0 0 0 0 0 0 0. That is for all three. The positives, same. Negative, it's difference. This is for the first one. The second one is second one. This is in sign and magnitude, and this is in 1's complement, and this is in 2's complement. You have to add 1. Add 1 will make this all zeros. So you have only positive 0. You don't have more negative 0. No negative 0. So now the issue is solved. Because you can add 1 and see. Add 1 to this, and this will become positive now. If you add 1 to this, all ones will become zeros.
Now there'll be another 1 in the end, no?
But you have only 8-bit register. You can add 1 to the end. That is 9-bit. But that won't be there in the 8-bit register.
Yeah.
So if you re-add that one, then what will happen? It will become positive 1. Right? So then what is the enable on a bit? You have to re-add that bit. So even re-add that, so that will become positive 1. So minus 1 to 7 is like first one minus 1 to 7. 7 minus 1 to 7. The second one minus 1 to 7. Third one minus 1 to 7. Okay.
Now why do you represent by 1 1?
Sorry?
No, 1 to 7 value is 1 0 0 1 0 0 1 1, right?
1 to 7 value.
Yeah.
Yeah.
No, like why do you put like 1 1 1 1 1 1?
So that is the value. Did you divide 1 to 7?
Yeah, I got 100 111.
Sure. So
yeah.
So divide again and see. 1 to 7 divide by 2 is 63. Remaining 1. 63 divided by 2 is 31. Remaining 1. 31 divided by 2 is 15 and remaining 1. 15 divided by 2 is 7, remaining 1. Check the calculations again. 7 divided by 2 is 3, remaining 1. 3 divided by 2 is 1, remaining 1. So it is 1 1 1 1 1 1 1. It's calculation error. Okay.
Yeah.
So here actually the advantage of the 2's complement is you don't have negative 0. You can do this addition with so subtraction is not there. You can only do the addition, and overflow bit also you can ignore. Right? Overflow bit also you can ignore. So that is the advantage. So if you go and see how calculations happens here in the 2's complement. So basically here, okay, so let's say you want to calculate the same thing. Let's say same number. Let's take the same number. And let's calculate in 2's complement, right? This is I'm going to keep some space, and this is plus answer 0, 0, 1, 0, 0, 1, 0, 1, and the 2's complement will be 1, 1, 1, 1, 0, 1, 0, 0, because you have to add 1 to this. 1, 1 is 3, 3 plus 1 is 4, so this is 4. Okay, so then you have to add the numbers. So let's add the numbers. 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 2, remaining 1, and that one will come here. This will be 1, 1, 1, 1.
So that's the final answer.
Wait, I made an error, I think. So 1 plus, so this is 37, correct. Minus 12 is, yeah, correct. Then 1 plus 1, this is 1, 0, 0, 0. This is 2. This one will come here and it will be here. Here 0 plus 1 is 1. Okay. Then 1 plus 1 is 2. I made error here. 1 plus 1 is 2. This 1 plus 1 is again 2. This 1 plus 1 is again 2. There's a remaining 1, but you ignore that. There's a remaining 1, you ignore that. You have the answer. It is plus 25 here. Same. Understood?
Yeah.
You ignore the overflow bit.
But almost it's the same, right? For like, see, here over here you use this, right? You however get a 1 over here, and then in this, like, you add a 1, like you add a 1 in the whole thing.
Same, but the adding will be done previously, right? Adding will be done previously. So actually, it has done it has done a change, major change. That is removal of this negative 0.
Yeah.
Removal of this negative 0 is happened because you added that 1 previously. Now you don't have negative 0. Instead, that what you have. So there should be somewhere no එක දැන් මේක නැති වුණ එක whatever disappeared should be somewhere no. So that will actually, so this is like, this is, if this is the scale, okay, if this is the scale, if this scale had, okay, let's say this scale had, I'm going to represent the positive 0 here and also the negative 0. So if let's say negative 0 is red color, right? Let's say negative 0 is red color. If the scale had something like this, by adding 1, the negative 0 is removed. So what should happen to the last digit then? Now you have added 1, so negative 0 will become positive 0. Now you have only 1 0. So there will be one additional bit in the last, that is minus 128. The range will be increased. You cannot represent minus 128 in other two number systems using 8-bit registers. Why? Because the minus 128, if you use 8-bit register, this is 128, right? 1, 2, 3, 4, 5, 6, 7, 8. And minus 128 is this. You need 9 bits. See, you need 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can't write 9 bits, no?
Yeah.
But so this one also, even you take the negative value, you have to write 9 bits. 0, 1, 1, 1, 1, 9 bits. This is in the second method. So you can't write that also. But So what about 2's complement? You can write this 1 0 0 0 0 0 0 0. That is 8 bits. 1 2 3 4 5 6 7 8. So like you just change this to 0. But you know that. So how to get the original value of this? You can invert this. When you invert, you will get minus 127. And then you have to add 1. Invert and or subtract 1 first. So whatever. Subtract 1 first. This is minus 127. Subtract 1 is minus 128. The removed 0, removed negative 0 will be added to the scale, and that will become minus 128. Right? So that's what happened in the 2's complement. You will have additional bit also. That is 128. Because in 1's complement, 8-bit register ranges for sign and magnitude, 1's complement, 2's complement. You can write like this. So sign and magnitude, it is minus 1272 plus 127. 1's complement, same. 2's complement, there's a difference. It's 1282, 127. Because of the removal of that negative 0. Understood?
Yes.
Right. So this you have to remember. Sometimes they might ask this as a equation. If it is an equation, it is 2 to the power n minus 1 minus 1. If they ask as an equation, 2 to the power n minus 1 minus 1 is how you find the normal range, right? But in 2's complement, there will be additional. 2 to the power n minus 1 means you can write 2 to the power, how many bits? 8 bits. 8 minus 1 is 7. What is the value of 2 to the power 7? 1 to 8.
Yeah.
Minus 1 will be 1 to 7. So this is how you find a general number. That 1 to 7, this is how you find. So if there are 9 bits, 2 to the power 9 minus 1 minus 1. Number of bits in the register. If there are 10 bits, 2 to the power 10 minus 1 minus 1. That is the last digit. Okay.
Yeah.
This is how you find the last positive digit. But negative digit, there's a small difference in this one, right? Only this one. Only in 2's complement, the negative digit has 1 more than the expected.
Yep.
Okay, now you can even answer the questions in Bachelor of Information Technology question semester 1 papers. Right? You can just go and see in Columbia University BIT degree semester 1 paper CS. You can answer these questions. You have that much of knowledge. So, but you don't need that up to that extent to answer A-level paper. So if you can answer that level, definitely we'll answer A-level paper. So no worries. So A-level paper, this question will be nothing for you. Okay, so with that, I'm going to stop. So take a screenshot of this as well, right? Take a screenshot of this as well and write down data. So how to find ranges and all. So then next day I'll discuss. Next day means we'll meet in Saturday.
Saturday.